Hey everybody, welcome to the shop. So today we are going into my final video in dealing with drivelines in automatic transmissions. We are going to be talking about torque converters. Torque converters are a rather simple object, but for as simple as it is, it's pretty spectacular to think about what it actually does. Now, torque converters are usually used with automatic transmissions. They can be used for manual transmissions, but normally they're on automatics. Now, I had previously done a video in dealing with basically the clutch and clutch pack for a semi, where I was doing the installation. I was talking about the friction discs and the way it's put together, and the hellacious time I had installing it on the guide rods and putting it back on, and my blooper when I let it go and dropped it all over the floor. So basically with torque converters, not as complicated, not as heavy, of course smaller. They pretty much look like a metallic donut. Now, the purpose of the torque converter is the same as the clutch, but instead of using pure friction to basically take the power from the engine, and using friction to slowly come in and start the spinning of the clutch and then going into the transmission, this uses either fluid or a combination of friction and fluid in order to take the power from the engine and drive it into the transmission. So what happens is, with this torque converter, there are several parts that you have to be aware of. These are the basic parts for all torque converters. Now this is going to kind of vary because some are a little bit more complex with more clutches and things like that, but this is just the basic breakdown of the torque converter and how it works. So I'm going to put a picture right here of the torque converter. I had several pictures that I had taken while I was in the shop when we were working on a torque converter and pulling them apart, and I'll display a few here, but they weren't that good. They really don't show you how it works, so I found a picture that was used in class, and I found it online, so I'm going to show it here. It was pretty simple. Now, of course, people call the different parts different names, so bear with me. Principle is still there. They all work the same. So first you're going to start with the pump. The pump is mounted to the flywheel of the engine. Now the pump, as you see, it comes around and basically drives these fins, these impellers, which moves the fluid, because the torque converters are filled with fluid, with transmission oil. They're filled with the transmission oil, and these fins move that fluid, and basically the pump is driven by the engine, which then goes to the next part, which is the turbine. Now the fluid goes through the pump and starts to drive the turbine, and it slowly starts spinning that up. Then from the turbine, that goes back around through, and you see it goes in through the stator. Now the stator helps direct the flow. It usually sits on a sprag, and a sprag is basically like allows it to turn one way. It's like a one-way clutch, basically. It won't allow it to turn the opposite way. Different sprags do different things. So this will allow the fluid flow to turn in one direction and keep going and keep the fluid flowing. So you have to imagine basically the fluid is flowing around and into itself like a donut, because this thing is shaped like a donut. So all that fluid is flowing around as this thing is spinning and keeps going. At the same time, the entire thing is spinning in a circle. So you have the fluid spinning, kind of going in like, if you know what a maelstrom is basically a vortex of water out in the ocean. But imagining that water is feeding itself and going around and around, and at the same time rotating around. That's pretty much what's going on inside a torque converter. So it's taking the engine rotary motion, and then it starts to drive the fluid, which then drives the turbine and the stator, and the turbine is connected to the output shaft, which then goes to the transmission. So as that begins to turn, that starts driving the transmission. Now, these things will, like I said, vary in different parts. Some will have friction discs for clutches, so that you can engage and disengage for power flow. And they're really not that complex, but they're trying to make these more and more efficient. As these torque converters spin, they don't give you 100% power. So every gear that you hit, you're not reaching 100% efficient power. You're running at about 98, 95, or even as low as 80% efficiency as far as power. You don't really reach near efficient or 1-to-1 ratio until you have a full lockup of the torque converter, and it's at full speed or stall speed. Then it'll be locked up, and you'll be getting that 1-to-1 ratio from the engine to the transmission. So that's about the only time you have that. But as I said, you have the different parts. So you have the pump, which is driven by the engine. You have the turbine, which is driven by the pump. The fluid then flows back through the stator, which is on a sprag clutch, a one-way clutch, which keeps that fluid moving, helping it move in that circle while it's being spun around. Now, some of the things you want to be aware of when dealing with these is, for them to go bad, there's a couple of different things you want to look out for. One is contaminated fluid. Of course, contaminated transmission fluid leads to all kinds of problems. If you have a clutch or friction disc, it may not allow the release of the friction disc, or it may not engage the friction disc. It could be clogged or something to that effect, which would create problems as far as either stalling or not getting up to the right speed, or taking a little longer rev, or a little sluggish when you get going. You'll also hear noises, whines and things like that. This could be from the contaminated fluid. When you have contaminated fluid and it starts to get inside the torque converter, not only is it clogging things, it can start doing damage to the fins and whatnot inside the stator, or for the stator and for the turbine and the pump. So you start doing damage like that, you're going to have problems. The next thing is fluid level. Of course, a lot of contamination would come from a low fluid level, because you start to get that metal on metal, and you start to get the metal shavings in there and parts coming off. Needle bearings start to fall apart, and you start finding parts inside. This will also cause problems. So you're looking for contaminated fluid, low fluid levels. Also, with low fluid levels, you're going to get burning of parts. So you're going to end up having to change out quite a bit. If you start burning things up, you're going to start burning the oil. It's going to be useless. You're going to start burning up parts, so and wearing them out. And when, of course, metal heats up, it becomes brittle, so it breaks apart. So you want to look out for all of that. So that's the basic concept of a torque converter. Like I said, not a lot to it. The concept is really simple, but when you think about the fluid and how it has to react inside and spin around, as swirl around as well as spin, it's unbelievable just to think of the technology that goes into that. But thanks for joining me, and I'll check you out in my latest videos. I'll be going into my fabrication videos and dealing with a little bit of welding, and then I'll be on term break until I have to do another 6 more videos. So anyway, take it easy, and we'll see you around.